This video will cover section 4.3, and it is the video part 3. Yes, we have a part 3, not because not because the section was longer, but because I had to close the other video for some reasons related to the smartboard. So now, if you are in second period, you should be watching this video only, because we ended the class up to here, where I was telling you a quick way to remember what sine of 30 degrees, sine of 60 degrees, and sine, I'm sorry, not 60, but 45. 45, and of course this is 60. So we did that, and of course we know that the square root of 1 is just 1, so that's why the sine of 30 is just 1/2. And I told you for cosine, you can list them in reverse order. So the cosine of 60 would be the square root of 1 over 2. The cosine of 45, square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. So if you notice, in this case, they're going in ascending order, the roots. And for cosine, that will go, well, still in this direction, but they go in descending order. Now, if you know what sine and cosine is, it is pretty easy to find tangent, because we already know the tangent will be the ratio between sine and cosine. Now, remember how we said that the sine of 30 is equal to the cosine of 60. And so the reason for that is that 60 and 30 are complementary angles. And so whenever you have an angle, like the example of sine of 30, cosine of 60, whenever you have that case, we could say that those are called co-function identities. It comes from the complements, yes. And so we know here that the sine of theta, by definition, it is defined as the opposite side divided by the hypotenuse. And the cosine, well, let's show with the image. So the sine of theta right here. We have the opposite side is right here, so that's A. And the hypotenuse is C. Now, we know that this angle is 90, and even though we don't know what the measurement of this angle is, we know that it is 90 minus theta. Why is it 90 minus theta? So the sum of the interior angles of the triangle is 180. So if we subtract this angle here, 90, and then we also subtract this angle here, theta, we will end up with 90 minus theta. And so that is this angle right here. Now, to find the cosine of that angle, the cosine is defined as the adjacent divided by the hypotenuse. And so the side that is adjacent to this angle here is going to be the side that is actually forming the angle. So this is the adjacent angle, which happens to be A, and the hypotenuse is C. And so again, we have seen here that those two are co-function identities, and so therefore they have the same trigonometric value. Now, we have here a summary of the co-function identities, and I do not want you to confuse them with reciprocal identities, because if we are talking about reciprocal, the sine of theta will go with the cosecant of theta. The cosine of theta will go with the secant of theta, and tangent of theta will go with cotangent of theta. Now, in this case, they're not reciprocal. This is totally different, and it is co-function. So for co-function identities, sine goes with cosine, or cosine goes with sine, same thing. And tangent and cotangent is the same case as the reciprocal identities, they go together. And secant will go with cosecant. All right, and of course, if we're talking about radians, instead of using 90 degrees, we will replace that with pi over 2, because that is equivalent to 90 degrees. So let's move on to the next slide. So we're going to find a co-function for the identities listed here, and remember, sine is going to go with cosine. So sine of 72 degrees is the same as the cosine, as the co-function identity for it, of 90 degrees minus 72. And so that will give me cosine of 18 degrees. For the next one, we have the cosecant of pi over 3. Now we're talking about radians. So the
This is Elsa.
co-function identity for cosecant is
She's
secant.
recording a video.
In this case, we will use pi over 2
Okay, all right.
minus pi over 3. Now I'm going to perform that operation, subtract pi over 2 minus pi over 3. They have different denominators, so the common denominator is going to be a 6 because that's the product of 2 times 3. Right here, what we're doing is we're multiplying top and bottom by 3. So this will be 3 pi over 6. For the second fraction, we're actually multiplying by 2, top and bottom, so that will be 2 pi over 6. Then, just to finish this problem, it will be the secant of 3 pi over 6 minus 2 pi over 6 will be pi over 6. And that is for co-function, not reciprocal, co-function. Now, for the check from 5, I would like for you to try this on your own. So I'm going to pause the video. You pause the video also, try it on your own, and then check your answer with mine. So here are the answers for check point 5. Now we had the sine of 46, so the co-function, and I actually made a mistake. So the co-function for sine is cosine. So we take the cosine, and of course we have to use 90 minus this angle here, 46, and so with that I got 44. Now for cotangent, the co-function identity of cotangent, oh my god, I made the same mistake, sorry. So instead of cotangent, what I need here is actually tangent. And in this case, we don't have degrees, we have radians. So instead of using 90, I'm actually going to use pi over 2. So pi over 2 minus the angle, which is pi over 12. And in this case, I had to convert my pi over 2 into 12. So that would be 6 pi over 2 minus pi over 2. And that is how I got 5 pi over 2. Now I'm going to go to the next. I'm sorry, not 5 pi over 2, but 5 pi over 12. So let's go to the next slide. And now here we're going to have to write a couple of definitions. So first we're going to talk about the angle of elevation. So the angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the horizontal. So right here, this will be our horizontal line. It is parallel to the ground level. And so we have the observer, which is, he's standing here. And the angle of elevation will be the angle formed by this horizontal line and the line, I guess the observer is looking at the airplane, the angle formed by that imaginary line that goes from the observer to the airplane and by the horizontal. So this angle right here, that is what we call the angle of elevation. Now we also have the angle of depression. And this will be an angle that it is formed by a horizontal line in the line of sight to an object below the horizontal. So here we have the same observer, but now the observer is going to be looking at the car that is on the road. So again, this angle will be formed by the horizontal line and that imaginary line that connects the side of the observer to the vehicle. And so that angle formed by those two lines will be the angle of depression. So we're going to be solving a couple of problems that involve angle of elevation, angle of depression. And we have here a drawing, and we have the siding the top of a building. A surveyor measured the angle of elevation to be at 22 degrees. And this is angle of elevation. So here is the observer. And the angle of elevation is being made with this line, and the angle. You just lock the door, please, and no one else can come in. Now, the transit is 5 feet above the ground. So the 5 feet above the ground is actually this little space right here. 5 feet. And 300 feet from the building. So from here to here, we have 5 feet. Not 5, but 300. Okay, so going back to the problem. So here the question, we have 5 feet of the ground, we have it marked right here. We also have that the distance from the observer to the building is 300 feet. And so what we need to find is the building's height. So we're actually finding the distance from here to here. Now, in this case, we're going to be using the triangle that is formed by this line. This will be the height. And right here, this will be the hypotenuse. And of course, we don't have the measurements of all, but we do have a 300, and we have here the variable a. Now, if we consider that we're finding the opposite side to that angle, and we do have the adjacent side of that angle, which is 300 feet. Opposite and adjacent, I could use the trigonometric function tangent. So tangent of not theta, we actually know what that angle is 22 degrees. And so remember that will be the opposite over the adjacent. Now I'm going to put values into that for a variable. And the opposite side is being represented with a. The adjacent side is 300. And so here, what I need to do is solve for a. We know that 300 is dividing to the a, so what I need to do is multiply by 300. And so at this point, you will have to use your calculator. And if you do that multiplication, you will obtain. Okay, so to find the answer on the calculator for this problem, I have my calculator open here. And what we're going to do is, first of all, we have to make sure that we are in degrees, because the angle was given in degrees. So you can go to home, then go to settings, which is number 5. And then document settings, which is number 2. And then right here on the second option, not that one, but the second one, we're going to select degree. You must press enter, And then you must go down here and make a default. And of course here you will say okay. Now I'm going to go to the calculate section, which is here. And then I'm going to enter the problem, which was 300 times, and the tangent, you can find it here under the trig button, and you can find the tangent function. And as you see, parentheses will open automatically, so you can enter your 22 or 22 degrees. And I would suggest that you press Control Enter so that you can get a decimal approximation for the solution. So that will be 121.208. So I'm going to go back to the problem. And so we have 100 and I forgot what it was, 121.08. However, the question, it is asking us to round to the nearest foot. I believe that is somewhere there. Keep in mind that answer for 121 is the answer for from here to here. To that, we still need to add this height, which we agreed before, it was 5 feet. So to find the height of the building, it will be A plus 5. We already know what A equals to, and we are approximating that to the nearest foot, which is 121. 121, we add 5, and that will be 126. And the units, of course, we're talking about feet, so it would be 126 feet. So that will be the answer for that particular problem. Now, the last two problems of the section 4.3, we are going to do a checkpoint of checkpoint 6, which is very similar to problem number 6, the one that was on the previous slide. This will be the last slide of your. And so we already know that we're going to use one of the trigonometric functions, and of course we have options. Such as sine, cosine, or tangent. So we need to look at what we have or what we are looking for. And so we can see clearly here that we have 75 yards. And this one, since it's the side attached to the angle, we could call it the adjacent side. Now, we need to find, if you read the problem, we have to find the distance across the lake, which is this one here. And that is represented with the letter A. Now, that side is actually opposite to this angle, correct? So if we have opposite and we have adjacent, which trigonometric function could we use that has those two? Tangent, yes. So opposite over adjacent. So now what I'm going to do is write them down here. So I'm going to say the tangent of 24 degrees is equal to the opposite side, which is being represented by letter A, divided by the adjacent side, which is represented by 750. Now, to solve for A, we need to take care of the 750, which is dividing the A. So if we move it across, it will be multiplying. And so when you enter this on your calculator, you're going to get an approximation for it. So what we're going to do is you need to go to the trig menu, trig button, which is right here next to number 7. And then we're going to choose tangent. Well, actually, how about we write down the constant? Is it 750? Yeah. 750 times the tangent of, was it 24 degrees? Yes. Okay. And I'm going to press Control Enter. And that will be 333.922. So going back to the problem, the answer for A will be, I forgot what it was, 333.922. Okay, And so that will be the measurement for the distance across the lake. Now I'm going to do the very last problem, which is example 7. And now in this case, we're going to have to use something a little new, but I'll show you with the calculator. These are those problems where you have to use a calculator. So if I do include something like this on the test, I don't know if you noticed, but your exam is actually divided into 2 sections. And so if I include problems like this on the test, they will be on a Friday. And I want to split your exam so that it's not so overwhelming. So your first exam will be part 1 on a Monday, and then the part 2 on the, the part 1 on a Wednesday, your B day, right? Mm-hmm. Your B day. If you're A day, your exam will be part 1 on Wednesday and then part 2 on Friday. If you're in B day, part 1 on a Thursday, part 2 on a Friday. So in this case, all these type of problems that will require a calculator will be given to you on Friday. All right? So, okay. So let's look at the problem, and we have a building here, we have a shadow, and that shadow will actually be here, right? And on the problem it says that the shadow is 25 meters long. And we also know that the height of the building is 21 meters. So now in this case, what we're trying to find is the angle of elevation. And just quickly, since you guys just came here 7th period, and I was recording this with my 2nd period, let me show you quickly what I'm talking about with the angle of elevation. So the angle of elevation, it is the angle that is formed by a horizontal line that is parallel to the ground. So made with that line, and then in this case, this little guy here is looking at the airplane. So that imaginary line, which is the line of sight, and the horizontal, that forms the angle of elevation. Okay, so it's like you're here and you're just kind of like lifting your head, looking at something. So that angle will be your angle of elevation. All right. Now the angle of depression is kind of like the opposite. It's not just a sad angle. All right. Is you are like looking down. So that will be your angle of depression. So it will be formed with a horizontal and then that line of sight of if you were looking down. All right. So in this case, this will be angle of depression. Going back to that last problem. Here the question is, what is the angle of elevation? Right here. So our question is, what does theta equal to? So we know that we have the measurement of the opposite side, and we have the measurement of the adjacent side. So again, we're going to use tangent. So tangent of theta is equal to the opposite, which is 21, divided by the adjacent, which is 25. And that doesn't tell us the answer for theta, right? Not at all. So what I need to do is find an inverse operation that will take care of that problem. And when I say inverse, I'm talking about operations that will, one that will undo the other, such as multiplication, division, addition, subtraction, squaring, taking the square root. So the inverse operation for tangent is actually going to be, you guys ready? Tangent inverse.
Oh, wow.
Just like finally theta was.
No, because the tangent and the angle are not multiplying each other. They're in fact kind of like together. So the tangent inverse, of course, will undo tangent. And now on the calculator, we actually have a function. Remember, it's 21 over 25, okay? We do have a function for that. And if you press that trig button, tangent inverse is located here. Do you guys see it? Yes? Okay, and that was 21 over 25, correct?
Yes.
And let's press Control Enter. And so we get a value, and that would be 40.03. I believe the problem might say something round to the nearest degree. So in this case, we will just take 40 degrees, all right? 40 degrees. Now, one thing that you guys missed, because like I said, I started recording this with my second period. To make sure that you're in degrees or radians, you will do it this way. You go to the home screen, and you go to the settings, which is number 5, and then document settings is number 2, and then you're going to have to go to the second option, which is angle. And here we can go from degrees or radians, all right? And you're going to be doing this a lot. Okay, I get so tired of it. So degree, once you make a selection, you have to make sure that you make it default, all right? So you have to press that button and then OK, so that the change can take place. Okay, so this will be the end of section 4.3.